Well, I'd like to introduce you to the discrete LED and especially two important interface circuits based on current sourcing and current sinking. To begin with, LED is an acronym that means light-emitting diode. Here's a typical LED of the red variety. All of the action occurs up in the plastic body, and then we have two leads coming out. The flat side of the plastic body designates the cathode. Also, you'll notice that the cathode has the shorter lead. In terms of the schematic symbol for the diode, we have the straight line designating the cathode, and the other side of the diode is the anode. I like to think of the body shape of this diode symbol as looking like an arrow that indicates the preferred direction of current flow. The light-emitting diode is like other diodes in the sense that it only allows current to flow in one direction. If we tried to back up current against that cathode line, then no current would flow. The longer lead is the anode. So current to activate the element up on top needs to enter the longer lead and then exit the shorter lead. Now, when the LED is glowing, it has a certain voltage drop associated with it. That's called V sub D. This value is approximately constant, especially when the current flowing through the LED is at least 1 milliamp. Well, I'd like to introduce you to two basic interface circuits. And let's begin with the myRIO MXP connectors. We're going to connect the LED to DIO 0, that is the digital output number 0, which is on pin 11. And I will need to make use of the ground pin, or at least one of the grounds, which is located on pin 6. I'm using the DIO in the output mode for this application. And as an output, the DIO has approximately 3.1 volts in the high state and approximately 0.0 volts in the low state. Now, the first interface circuit to know about is called current sourcing version. We accomplish this by connecting the cathode to ground, and then generally we're connecting the digital output to the anode side, but we need a current limiting resistor in between. I'll call that R sub lim. Come back to that limiting resistor here in just a little bit. Now, this is the direction of current, I sub D, when the LED is active. To accomplish this, we need the digital output to be in the high state. That causes the LED to turn on. If we change the DIO to the low state, there's no impressed voltage across the diode, and the current goes to 0, and the LED shuts off. Let's put that back into the high state again. And we discussed earlier that we have a voltage roughly about 3.1 volts appearing between the DIO and ground. Now, as I mentioned earlier, the diode has approximately constant voltage called VD. It's roughly 2 volts for a conventional red LED. The current limiting resistor is what allows us to set the amount of current I sub D that flows out of the DIO on its way to ground through the LED. Some quick circuit analysis here says that the voltage that appears on either side of that current limiting resistor, 3.1 volts on one side, 2.0 volts on the other, divided by the value of the resistance is equal to the current through the resistance, which is the same thing as the diode current. I'm going to interchange those two so I can solve for the limiting current or the limiting resistor value. Let me choose 5 milliamps. It's a pretty decent amount of current to light this LED. And that tells us we need a limiting current limiting resistor value of 220 ohms. Now let me acquaint you with the current sinking version, and I'll kind of develop this based on what we know about current sourcing version. Current sinking works like this. We still need to flow current in this direction through the diode. We could also accomplish that by, instead of using ground, using a digital output right here. Then to establish this voltage of roughly 3 volts, we can change this out to the positive 3.3 volt supply. Now we can establish this voltage of around 3 volts by ensuring that our digital output is set low. In the low state, 0.0 volts is very much close to the ground. Now 3.3 volt supply is up here on pin 33, kind of a convenient number. Pin 33 for 3.3 volts. When we put the DIO in the low state, current flows from the source through the diode on its way to ground, and we say that this is an active low control or interface circuit for the LED. Now, shorter wavelength LEDs like green, blue, violet, and white have a voltage drop that's higher, more on the order of about 3 volts. And that means you can connect them directly to the DIO, and you can omit the current limiting resistor altogether. Well, hopefully that gives you a better sense of the discrete LED and basic interfacing techniques.